All right. What did I say about all nitrates? All nitrates are soluble. All acetates and nitrates soluble. All group 1 metals and ammonium is soluble. Then when you talk about chlorides and sulfates, you have exceptions, right? So for chlorides, Maya, do you remember what the exceptions might be? Potassium. Remember, potassium is a group 1 metal. All group 1 metals and ammonium are, right? Close, bearing this with sulfates. If you're stuck, what should you do? If I ask you a question about solubility and you're stuck, what should you do? Yes, so you should all have been looking at the data sheet and give me an example. But I'm going to save us time. Get your data sheet out still. You can't do chemistry without one. Silver chloride is an example. So silver chloride, well, ionize as such. Now, Mithilesh, give me a common ion solution. So what can I add to this saturated solution to decrease its solubility?
Sodium chloride.
Okay, sure. Sodium chloride is one addition. Gerald, give me something else.
Potassium chloride.
Okay, good. Which working with other group 1 metals and chlorides. You could also consider something like silver nitrate, right? The key principle here is when you increase the concentration of any of these aqueous species, I should be writing Cl minus, what will it do to the equilibrium, Pranav? Which way will we go? Yeah, it will shift back to the reactant side and will form more solid, aka decrease solubility, form more precipitate. Does that make sense? That's the common ion effect in a nutshell, right? When you increase the concentration of any of the aqueous species of a saturated solution, we'll shift the equilibrium to the left, we will form more precipitate. Now that's quite easy. The only thing you need to remember now is common ion effect, LCP. That's how you explain it. Now when we talk about the calculation side of things, did you go through that? How to quantitatively prove the common ion effect. Okay? So I'll give you an example question. So question 2 here. Have you already done this question? Okay, it's a good question to get started on. So what I'm going to do is I'm going to give you all about a minute to start this question. I'm going to walk around and see how you're all starting this. Then I'll pick on one of us to answer this. Okay. So for all the online students, it's a question that I've circled. Yeah.
Well, I can't see the power for the 10.
Oh, it's to the power of negative 12. Okay. I can see you're all starting. Waiting for everyone to get up to one step before I ask you. Good. So the basic things I was looking for was equation and data. So you've all got that now. So Gerald, hopefully you've done the equation and data now. So what's your next step, Gerald? What are we doing here?
As in, you just want me to talk through my steps.
Yep. So what's your next step?
So because you know that NaOH has one sodium, one hydroxide, that means that in the solution there's already 0.75 moles of hydroxide in solution.
Good, right. So I guess the first thing I would do, everyone, is I've written my equation, number 1. Number 2, what should I always do? Good, so I need to do my data. So what data do we have? Yeah, very good. You always have your KSP of your insoluble salts. So you could have found this, they shouldn't have given you that. You should have just looked at your data sheet. So it's 2.2 times 10 to the power negative 20. We're always at 25 degrees. Why have they given me 25 degrees? Good. The one factor that affects K is temperature. Good. And, all right, so we've got 2 scenarios, you'll agree. For me to show that the solubility of copper hydroxide will decrease in a common ion, I need to take 2 thought experiments. These are going to be 2 different calculations. I'm going to first find the concentration of ions in water, and then I'm going to find the concentration of ions of a saturated solution with a common ion. And the goal here is to show when a common ion is present, the concentrations of these aqueous ions goes down. That shows that the solubility has decreased. Does that make sense to all of us? That is the end goal. If you show that, you're done. So first thing we're going to do is we're going to do a thought experiment in water. So in water, we've got this KSP value. Whenever you have K, especially KSP, what can you find from it? of? Good, right? So what K always helps you find correctly is concentration of aqueous ions. So it's not so hard right now, right? All we need to do is, well, we know the KSP equation is going to be equal to the concentration of copper times concentration of hydroxide squared. If we let copper hydroxide equal X, right, or the number of moles, the concentration of copper hydroxide that actually dissolved equal X, what's going to be the concentration of copper ions? Quickly, and hydroxide? Good. Always do this, just so you don't make silly mistakes. Now, when you sub this in, it's just going to be X times 2X squared. What do you notice? The number inside and outside the bracket typically is the same. Always check that in your head. It should be a little mental checkpoint for you. Okay? What is going to be our answer? So we've got 4x squared, no, cubed, sorry, equals to 2.2 times 10 to the power negative 20. Mithilesh, actually reassign. What do we get as our answer for x?
For x, I got 1.77 times 10 to the minus 7.
1.77 times 10 to the power minus 7. Okay, does everyone agree?
Moles per liter.
Good. Moles per liter. I'm just going to put a capital M. Now, what is that referring to? What is x? Good. Solubility of copper hydroxide, or the solubility of copper, or the solubility of the hydroxide ion. Now, I have a question for all of you. You need to compare the solubility of one of these ions. Which ion are you going to compare? We've got, let's go back to the question so you can see it. It's copper hydroxide in water, and it's sodium hydroxide. There are two things you can compare. You can either compare, as Mani has mentioned, the soluble copper hydroxide in both cases. What else can you compare? Can you compare hydroxide? But would you compare the common ion? Because what's going to happen, think about this, you've added that common ion, right, in the common ion solution. So you're going to say its aqueous amount increased. So you're going to be able to prove the common ion effect. Sodium, copper. The two things you can check is you can either compare the solubility of aqueous copper hydroxide, as Maya's mentioned, or the other ion to the common ion. You can't directly check the common ion because you've added the common ion in the common ion solution. When you find the ion concentrations, it's going to be higher. You want to show it gets lower. So you need to always check the overall salt or the other ion to the common ion. Maybe write that down so you know your plan of attack now. Okay? Good. We should be able to logically think of this in an exam. All right, let's move on. So we've done, so we're just going to say X is equal to concentration of copper hydroxide that was aqueous. That's equal to X, but that's also equal to the concentration of copper 2 plus itself. Does everyone agree? Good. Now, Gerald, take me through what's going to happen. You started us off. You said that we already have, so in a 0.075 moles per liter sodium hydroxide solution, Gerald, you mentioned that the concentration of hydroxide ions is already how much?
0.05 moles. 0.075 moles, yeah.
Okay. Good. So you've already got an existing concentration of this amount here. Okay. So what's your next step, Joe?
Then using stoichiometric ratios, you can determine change. So change of copper ions will be X, and hydroxide ions will be 2X.
Okay. Very good. Joe, do you typically need to use ice tables for KSP questions?
It's like nicer to show working out, I guess.
Good. But I would say in a KSP question, me personally, I don't think I've ever had to use an ice table. Because the beauty of KSP questions is that you have a solid, which you never have to know its concentration because it's constant, will form two aqueous species whose concentration was initially zilch. The change is always going to be the final. That's why doing an ice table is a bit redundant. You can logically always do these without an ice table. Okay? So continuing on, will the KSP value change for the salt? We've got a common ion now. Will the KSP value change?
No, it won't, because it's constant temperature.
Exactly. So we're going to write KSP is now equal to X, which is, we'll do full working out. So KSP is equal to concentration of copper times concentration of hydroxide squared, right? That's going to be equal to X for the copper But for hydroxide, what do we have now, everyone? 0.075 plus 2x. Do you all agree that this copper hydroxide is also going to ionize and form X moles per liter of copper and 2x moles per liter of hydroxide ion? Does everyone agree? Right? So on top of the 0.075 that's already been released in solution from that common ion, our actual salt that is going to form the saturated solution is going to give off 2x of hydroxide ions. So you need to show this step of working out. It's 0.075 plus 2x. Good? Yeah, it's going to be squared. The whole thing will be squared like that. Now, this is the issue though. What kind of equation will we form now? Good. 2 maths comes in handy. Quadratics. Do we need to know quadratics for chem? So for chemistry, for simpleton purposes, we will round up only this x value. We'll assume it's so small compared to the 0.075. Say it's 0. Think about why we made that assumption, right? In a saturated solution of water, everyone, the concentration of the concentration of copper ions is times 10 to the power -7. Hydroxide is comparable to that. Do you all agree? So it's just going to be 2 times whatever that 10 times -7 value is. It's going to be even less in this scenario because of the common ion effect. That is why we're rounding it up to 0, because it's so tiny. Okay? So you need to write this statement as well. And finally, you can just say that's equal to x times 0.075 squared. All right, tell me what x is and tell me what our answer is going to be. The common ion effect questions are not too hard at all. And after this, we're going to start doing some 2020 trial paper questions. Mithilesh, what's your answer?
For x, I got 3.91 times 10 to the power of -18.
-18?
Yeah.
Okay. Now, Mithilesh, can you comment on the change in the concentration now? So this, as we know, is still the concentration of copper ions, and it's also equal to the concentration of copper hydroxide. That's actually aqueous. So do you think this is a small change in concentration, or has it been magnitudes of difference?
It's like much smaller.
Yeah, does everyone realize that? These are 2 very tiny numbers. The brain can't comprehend numbers this small. But I want you to compare the relativity. The solubility has decreased by multiple magnitudes. There's a huge decline in concentration. Does everyone see that? So what we can say now is therefore, we can say therefore, due to common ion effect, I'm just going to call it common ion effect, you should say the full term, concentration of copper ions in water is greater than the concentration of copper ions in your common ion solution. You always need to have a final statement, especially when you're proving things in chemistry. Okay? Yeah?
I think Neha told us to divide the 2 solubility, and then you can get like a value. Do we have to do that?
So to do what? Convert this into a solubility value?
Yeah, no. She divided the solubility in water by the solubility in the solution.
You could. That definitely could work. And then you'll show how many magnitudes it's decreased by. But that's not necessary. Like, you don't need to do that. If you'd like to, you can, to show the marker. But as long as you show the concentration in water is greater than the concentration in a common ion solution, you'll get the marks. Okay. Good. And to be safe, just a 1-line word statement is what you need at the end. All right? Well, congratulations, and I'm happy with what you learned last lesson. So, does anyone have any questions on Mod 5? You're quite confident? You feel relatively okay with 5? 5 is the easiest module, right? So, we learned it very fast, and I guess for a reason. Now it's all about fine-tuning it, because if you found it easy, just imagine, Dangerous, Balcombe Hills, North Sydney, all the other schools also found it very easy, okay? So I guess it's your job now to perfect it until it becomes very easy, okay? Good. Who's aiming to be rank 1 in chem at school? Rank 1 at school. What rank were you all last year? 70?
Yeah,
70?
Yeah.
Ooh, right.
I was very drunk.
Oh wow, really?
I got rejected. I need to study for the test.
Oh. Wait, you got rejected from dropping chem?
Yeah.
You weren't allowed to drop it?
Yeah.
What? 100?
Very, very low. Like 7 or 8, but my class is very small.
No, this is good. You know what this means? You're all the underdogs, right? And I guess the thing is, you don't have much to lose, you have everything to gain, which is a good thing. I think you have to realize this. The rank you had last year was squat, right? I don't even know if I was rank 1 in year 11, but I ended up smashing everyone in year 12, right? The reason being, this year, if you put in the work, you stay disciplined, and you learn efficiently for chem, you can come first. So all of you at your schools can come first. There is a very good chance if you put in the work. Okay? So make that your goal. I want to see some of you coming first. That will be my goal this year. Okay? So make sure you do that for me. Alright? Okay, so let's get started. What I'm going to do now is I'm going to throw you on the deep end. What I mean by that is you're getting 2020 trial questions that you have not seen before because these are 2021 papers, so they're not in your additional questions either. And we will likely start Module 6 maybe the end of this lesson as well. Okay, but I want to make sure you're all very confident with 5. Alright?
How do you get the 2021 trial papers?
I have my ways.
How do you say Like, did they upload it after they did it?
Yeah, a lot of, see, this is from the altruism from a lot of ex-students. They wanted to help future students out as well, so they've given their papers for all of you to also practice on. So, yeah. Alright, first question I want you to do.
Which paper is this?
This is the Abbottsley 2021.
Okay.
Okay, so I'll pick the questions for you to do. Here's your first question. I'm not going to say anything at all. With these, since we're doing practice questions now, it's not going to be my job to guide you to the answer. You come to your answer, and then we fine-tune your method of approach. So you all have 1.5 minutes to get as fast as you can to the question. So jump into it. In exactly 1 minute, I'm going to start picking on people. So go as fast as you can. The goal is speed. Okay? No matter what, start writing down. I want all to be pretty pen to paper. The aim to come to your answer first. What's the first thing you should do? I know you don't have the paper right in front of you, so I know a lot of you are just rewriting the data. What's the first thing that should be done? Equation, right? So I don't see all of you writing equations. What you should be doing first. First thing you should have done is your equation. You can put your data all around the equation, right? Good. And it's a bit of a visual question, helping you out. You can redraw the diagram. You should be doing that if you're stuck. It should literally be equation, data. If you're stuck with the steps, do a diagram. Okay? Okay. I want you to do me one quick favor. Pause. I want you to stop writing what you're writing. And I want you all, in 10 seconds, pick A, B, C, or D. I know this sounds very hard, but use your logic. Don't use maths now. Is there an overlying logic to this question where there may not be too much maths involved? Yeah? So what could the answer be, just looking straight at this? Pardon? Let's see. What do you think? Before you say your answer, that was B. What do you think? B?
I was very big.
Very B?
Yeah.
Isn't, Okay, this isn't like course study. I want to
Yes,
examine logic behind
logically.
it. And Mithilesh, what's your answer?
B.
B. And what about rear sight?
I thought it was C.
Okay, now, can I explain your logic to C?
So I literally just did 60% on the year. And I didn't care about the end. And because I'm 200 mils of water. Equals to N.
Okay, even though that's maths, everyone,
Can I say
here,
that?
no matter what the mass of lead that was added, there's only a fixed amount that can dissolve. Everyone agree? Right? And this is per liter. There's a fixed amount that can dissolve per liter. Now, do you agree the amount that was added is much more than the amount that can even dissolve in 1 liter? So what do you think if it was in 200 or 100 ml? Do you all agree? Both solutions, we've added too much of our salt, right? We agreed to have some precipitate. So in both cases, we would have already dissolved the max amount of ions possible, which is 0.76 per liter. Now, we would have dissolved the max we could dissolve in 200 ml, the max we could have dissolved in 100 ml. How much more would dissolve in 200 ml versus 100 ml? Double. So what should the ratio be? 2 to 1. And what option is that? C. That's the logic. Now prove it. Go. So what I'm showing you is you should be able to, number one, think about this conceptually, number two, do it mathematically. So prove it to me mathematically. Okay? Mithilesh, did that make sense as to why?
Wait, Prithvi,
Yeah.
isn't the concentration of both solutions the same because solubility is constant?
Yes, no, you're right. So now since the volume is
It's double. So shouldn't it be A?
should it be A? Well, I guess we'll find out. I do agree with you in that now since the volume is doubled, I'm not quite for that in the final point. But what I said up until the number of moles being soluble is correct, right? There's going to be double the number of moles
Oh yeah.
soluble in bigger R. And from there, I guess the question is talking about concentration. So you can probably work out what could be the answer based off that. But do it mathematically and you come to your actual final answer.
Okay.
Good point. You are right. That I was talking about moles, especially about concentration. I haven't factored in volume. Yeah, I think when we do factor in volume, it should be, as Joe was saying, 1 to 1. Okay, I guess we'll very quickly do this because we don't have too much time. I don't want to spend way too much time on a single question. But I guess the only thing you have to do here is quickly error check, right? And what I mean by that is very quickly write your equation, which is PB I2 will form PB2 plus and 2I minus. Okay, and what's the Ksp that we know for this equation? Good. We don't really need that given that we've kind of been given the solubility. So we'll say concentration of PbI2 max is equal to 0.76 grams per liter. So we'll start with bigger R, right? Do you all agree if only 0.76 grams per liter to dissolve in 200 ml is going to be much less than that that's actually dissolving? Right? So let's actually find that value out. So what is the bigger R in 200 ml? So when V is equal to 200 times 10 to the power negative 3, what is the concentration? Oh, sorry, it should be what is the mass? That's what I'm asking you. What is the mass of lead iodide, that max that can dissolve? So we've got 0.76 grams per liter and 200 ml. So it's going to be 0.76 grams per liter times 0.2. Does everyone agree? So what's our answer? 0.152. Yeah, very good. 0.152 grams. So that's the amount that is dissolving. Does everyone agree? All right, good. All right, and what about for B gas? Yep. 0.076 grams. Okay, now what you could do is convert this to moles, divide it again to find concentration in moles per liter, or we can now logically think, okay, well, they simply ask for concentration, right? We could logically work this out comparing mass per liter as well, right? So in both cases, what's the concentration of lead iodide in both solutions? Yeah? Yeah, what is it? You don't need to calculate it. It's right there. Right? Do you all agree? Per liter, that is the max that can dissolve. Anything more than that has precipitated out. You can double check your working out and see if that's right? But you should get the same. So I guess we didn't even need to do any working out for this question, which is what I wanted to show you. You just need to start doing mathematical working out. And I guess if you're stuck, what you could have done, you could convert this to number of moles. You could divide by that volume. You could convert this to number of moles. You could divide by this volume, and you would get the exact same. Okay? But I guess that's what this question was checking. So I do agree. Gerald, correct. But the answer should be A. Does that conceptually make sense? Right? No matter how much excess you add, it doesn't matter. Right? Because that amount of ion, the max that can dissolve, has dissolved to that concentration, and it'll always be equal. Okay? Good. So if we had a 400 ml solution and I added 10 grams, what's the concentration of aqueous ions? 0.76 grams per liter. Right? Everything extra has precipitated. Good. This is more of a conceptual question. All right, let's do. Okay, here's your next question. This is a Spectra question. Oh, I can't see it? Same for you guys? Can the front see it? Okay, what I'm going to do is I'm going to screenshot this. I'm going to add it on our messages. Does everyone have Teams on their phone or device? Yeah, do you have your laptop with you? Good. So I'll add this on Teams for us as well. Okay, so let's do this question. If you can do this question, you understand Spectra. And you'll be ready for your test. Yeah. Alright, so I want us to start working with this. Good, and this is colorimetry as well, so it's exactly as Spectra as. These questions look very hard. Should be CAD something. Yeah, should be possible. This is stuck. Alright, so when you're stuck, what's the first step to do? I want you to realize this. You see the challenge that you feel right now with this question? Even when you are at the end, the day before your HSC, you're sitting in your exam, there'll be one question which is this level of difficulty in HSC pipeline. So I want you to be able to work your way out of these situations. The goal here is follow the exact same principles we've always done in class. So we're going to do this together now, okay? What is step number 1? Mithilesh?
Step 1.
Yep.
Draw a line.
What's the first step? The equation. That's what we need, right? Do you agree? That's what makes this question a little bit challenging. You've never heard of perfluorooctane sulfonate. But does it really matter if you've heard of it or not? Because they've told you here, if you read the question, it reacts with in a 1-to-1 ratio with iron 3 ions. So why can't we just call perfluoroocto whatever sulfonate it is? I'm just going to call it P. Okay, element P. And I'm going to react it with iron 3 ions, and guess what my equation is? I don't know that it's 3 minus, I'm just doing that to make it a 1-to-1 ratio. Okay, it doesn't matter what it is. We're just going to call it Fe. How easy was that equation? Just have to read the question, right? Okay, so what color forms a purple solution? We want to write all our details underneath, right? So purple. That's all I've gotten so far. Do we care about the firefighting foam or the stable effects? No, it's not going to help us with the question, right? So you need to know how to extract the relevant information. Let's keep going. To analyze the soil samples, all right, who read this section and got confused? Do you know why? There are many steps, and it's logical. I would be confused as well. So when there are many steps going on, what should you do? Yeah, but then I can just say, okay, break it down. You wouldn't know what to do, right? So what should you do? There's a lot of numbers and keywords still wouldn't be cleared up. Yeah, diagrams is what I would do. When you draw a diagram, your mind can grasp vast amounts of info. So let's do that first, right? So what's happening? So number one, 5 grams of soil is added to 15 ml of distilled water. So first, we're going to call it step 1, dissolving P. And what did we do? We had a beaker that had how much? Volume equals to 15. And how much P did we add? 5 grams. Not bad, right? We've got an M and a V. What can we find? There you go. See how now your brain's starting to work with these numbers? You wouldn't have understood it if it was just all crunched up in a paragraph. What's the next thing we do? The solution is then reacted. Okay, so what's step 2? Step 2 is we bring that solution, the same solution, and we're reacting it with iron 3 ions. We're just going to say Fe 3 plus. Okay, and what's the current volume right now? Volume equals to 50. And now can we maybe infer what the volume of the iron 3 ion solution would have been? Possibly 35. We don't know because it could have just been some iron and then we could add some water after that. It haven't been clear. Do you all see that? They just said the solution was made up to 50. We don't know if water was added or... Either way, it does not matter. Let's keep going. What happened next? Exactly 10 ml. So from that, we got how much? 10 ml. Everyone agree? So we say volume equals to 10 ml. Now I have a question for all of you. If I gave you a bucket, 50 ml bucket, and you scoop 10 ml out of the bucket, what would be the same about the 10 ml tube and the bucket? So write that. So write concentration equals to that value there. Or you could maybe call it step 2. Since this is step 2, we can say concentration is equal to the concentration in step 2. Something like that. Do you see how you're now computing this data much more? You need to be able to do this yourself. Okay, what happened next? It's then pipetted into a 100 ml volumetric flask. So this 10 ml is then made up to how much? What's happened? What do you call that step? Write it down. Dilution. And what happened in dilution? So that must have been C1. Does everyone agree? So let's call this C1 again. This is C1. C1. Now, what's the new concentration? C2. So do you agree, if the question is going to ask us what C1 is, we need to find C2, and then we need to apply dilution to find C1. C1V1 equals C2V2. Okay, so what's the volume of this stuff here? Yeah, so let's write that. 100 times 10 to the power negative 3. All right, and what's the absorbance of this conical flask? Good. Is it more digestible now to all of us? Does anyone see a plan of attack? I want you to now pause, and I want one person to tell me the plan of attack. Maybe I will ask Riyasat, what is your plan of attack for this question? I want one line. What are you doing?
For A or?
No,
Are
I
you
want you to go straight to the, like, pretty much find the, they're helping you with A. A, you literally look at the graph. But let's say you've done A, you found the concentration of PFOS, but how would you go to B? How would you find B?
I'd essentially just do the steps backwards, starting from, yeah.
That's what I want to hear. So you would find C2, you would work back to find C1, and once you find C1, well, you know, if you know C1, you know B, what can you find? You know C and B, what can you find? N, and you can work backwards until you get percentage weight per volume. That's all you need to do, right? So let's start doing this together. So part A, they helped you out here. I think they should have just given you part B, but that's pretty cool. So let's go to B. Actually, let's find A together. So zoom into the graph so you can all see it, for those of you who can't see it too well. It's 0.54 is the absorbance. So what's each increment, everyone? No, 0.2, so 0.54 is here, right? So what we need to do is we need to find the intersection in that graph. So 0.54 is right there, which is right here. So what is that value? 3.8, right? Good. Good. So then we'll write, therefore, C2 of P is equal to 3.8. Okay. Now, why should you be a bit cautious here? Because this is saying PFOS. Why should we be a little bit cautious? No, it's the same thing. We can call PFOS. I just shorthanded PFOS into P. Why? Yeah, so we added iron to this. Does everyone see that? We would have formed another ion, FePFOS, whatever that was, right? So you just need to be very cautious that you're working with the same variable here. So just have a quick look at this. We've got PFOS. But do you all agree it's a 1-to-1 ratio? Right? So you can work back and find PFOS either way. So as long as you realize, if you know the number of moles of FePFOS, you can find the number of moles of PFOS. It's a 1-to-1 ratio. Okay? So let's work through this. So therefore, we've got the concentration of PFOS is equal to, we said 3.8 times 10 to the power of -5. Okay. But that's also equal to the concentration of Fe PFOS or whatever that substance is. Okay, so we've got C2, everyone. What should we find now? Good. So I'm going to leave it to you guys to find C1. This is going to be our working section on the left-hand side. C1 equals C2, V2, and V1. Okay, what's our C1? Okay, did we all get the same value? Agreed? Yes. Okay. So we'll store that as A. Alright, so we're currently at C1. This is where you have to be very cautious, everyone. When you just write C, what is the issue that can happen? You can mix substances up. So what is C1? What have we found C1 of? Yeah, FeP. So we're going to write C1 of FeP is equal to this value here. Now, what was the volume? 50 ml, right? Do you agree we can kind of skip this entire section because if we know C1 in 10 ml, we know C1 in the 50 ml solution, right? So we're currently at this point here in our working out. So our volume of FeP was equal to 50 times 10 to the power of -3. Now, what do we need to find? Okay, we can find N, and then what can we do? Okay, now let's just be cautious of what happened here. So we've had P, and at this step, we added Fe3 plus until it was made to 50 ml, right? Now, what are they asking in this question? What is the concentration of PFOS in the original soil sample? percentage W/W. What does that mean? Yeah, but what does that mean? What per 100 grams? Grams per 100 grams. So this is what you need to also do. So do you see how we did equation, data? If stuck, what do we do? Diagram. And if you're still stuck, what do you do? Last thing I'll do is frame the question. Do you all agree we haven't written what the question is asking us to find? The question is asking us to find what is the concentration of PFOS in grams per 100 grams of the soil sample, right? Now, do we have the mass of soil? Yes. So what do we need to find? What is this question truly asking? Oh, yes. That is framing the question. Draw a little frame sign around it. Good. You frame the question. That's what we need to find. If you find that, you can find your answer. So, everyone, what do we do now? Currently, we're at C1 of FePFOS. So maybe I'll write FePFOS to make it clear. Reflesh, what should I do now? Any ideas?
Which part?
So we've currently found, we've got C1 of FePFOS. I've got V of FePFOS is this value here. What can I find now?
The moles in there.
Okay, sure, let's do that. So right, number of moles of FePFOS is equal to CV. What do we get, everyone? Quickly, whoever gets it fastest. So Gerald, Mithlesh, if you get it, the answer, just shout it out. Good. Did everyone get this? About 3.8 times 10 to the power negative 6. Okay, don't worry. Double check your answer and tell me how you got. And who else has got a? You got the same one? Okay, good. Now, question. This is a number of moles in 50 ml. Will there be a different number of moles in 15 ml? Because remember, we're going backwards, just like Riasat mentioned. We're at step 2 now. When I go back to step 1, is it the same number of moles? Different number of moles? You tell me. I asked you a question. Sorry, what do you think? This will show me whether you understand dilution and when not to do dilution. Gerald, going from step 2 to step 1, the number of moles. So we know that the number of moles of FePFOS is equal to the number of moles of PFOS because it's a 1-to-1 ratio. Does everyone agree? We're just applying this ratio here, right? My question though is, will the number of moles of PFOS change going from step 2 to step 1?
No, it won't.
Okay, good. We've got a definitive answer. Everyone agree or disagree?
Concentration
Is the volume decreasing it from 15 ml to 50 ml? Remember, where did the other 35 come from? It came from Fe being added, or water. We don't know, right? Now tell me this, why did we come to this equation C1V1 equals C2V2? How do you derive this? Well, what is C times V? Saying N1 equals to N2, because if you add water, the number of moles never changes, right? Imagine, you've got hand sanitizer, right? Let's say I've got 1 mole of hand sanitizer here. If I add 100 ml of water to this, will the number of moles of hand sanitizer change? Has any number of moles leaked out of the corner? The number of moles is constant before and after dilution. That is why you can apply C1V1 equals C2V2. So again, I will ask you, was the number of moles going to change? No. You can now clearly say the number of moles of PFOS in 0.1 is this answer as well. So you can say the number of moles of PFOS in 15 ml is also equal to 8. Now guys, remember step 1 is before iron was added. Right, so now we're finding the pure PFOS, not FePFOS, the pure PFOS. I've got a number of moles, what can I find? Yeah.
Arrow to A.
Yeah, so the arrow to A shows the marker that you've stored the value as A. So if what they can do is they can take away a mark, but then you can go and show them I've stored it as A, so whenever I wrote A enter, referring to that number. So you won't lose any marks. Okay, good. Alright, so what are we going to find now? Do we have the molar mass of PFOS? There you go. So you know you're doing something, right? So find the mass for me. Number of moles is equal to mass times mass divided by molar mass. Therefore, the mass of PFOS is equal to number of moles times molar mass. Mithilesh, what did you get as your mass of PFOS?
I got 9.5 times 10 to the power -3, but I don't know if it's right.
Did you do this method?
No, I tried doing it a different way.
How did you do it?
So I just converted into moles straight away, and then I just tried to work back from there. I don't know if it worked.
Okay, so while we were doing this, yeah, look, it should work. Okay, if you found number of moles here, Mithilesh, and you just went back up here and you used the same number of moles, you would not have got it correct. Because that step was not a dilution. Does everyone see that step there? From 50 ml of this beaker, we took 10 ml solution here. That is not dilution. Because we've taken a smaller amount of that 50 ml solution. The number of moles will be less as well. It's the concentration that would be constant. One squirt of this hand sanitizer has less moles in the bottle. But the concentration is the same. Do you all agree? So it all depends, Mithilesh. We'll find out. So everyone, what do we get as our mass of PFOS quickly? 1.0 times 10 to the power -3? 1.9. 1.9 times 10 to the power -3. Let's store that as D. All right, and we'll divide that by 5 grams. What do we get? Therefore, the concentration of PFOS is equal to D divided by 5 grams of soil. So what do we get? So that's the grams of PFOS per gram of soil. What is percentage weight per weight? Grams per 100 grams. So what should we do now? We know the number of grams in 1 gram. How do we find the number of grams in 100 grams? Times by 100. Does everyone agree with that? Yeah, you're going to times the denominator by 100, times the numerator by 100. Therefore, the percentage weight per weight of PFOS should be equal to 3.8 times 10 to the power -2 percentage W slash W. Good. Did everyone get that value? How many sig figs should our answer be to? 2? You need to be very cautious. See, we didn't use this 10 ml here, so I wouldn't count that. We did use a 50 ml, and where is this? That 50 ml is to 4 sig figs. What about this value here? When we got to times 10 to the power -5, we got 3.8, which is how many sig figs? 2, right? So our answer should also be to 2 sig figs. Okay, good. Try looking for 1 sig fig. Is 5 grams? No, see 5 grams is to 4. Again, I'd say it's probably 2 sig figs to your answer. Okay, good. Mithilesh, is that the same as what you got?
No, I got something different.
Okay, double check where you may have made any changes. So just double check your answer and find that out for me. Gerald, how did you go?
Yeah, I got another answer, but I get what you did. Yeah, I get what you done. Yeah.
All right, good. Does everyone understand the steps taken here? I know this is a hard question. That's why I told you we're going to go through hard mod 5 questions. Yes?
So yeah, now we use 10 ml.
Yeah.
Is that?
Did you use a 10 ml in the calculation? If you can find that you used 10 ml in the calculation, then you have to include it. But do you see how we didn't use it? We just found the C2 and we went straight to step 2. Does everyone see that? So I didn't use it, so I would not round it off to 160. But good. Good job, everyone. That was a hard question. Okay, but that's probably the hardest. This is technically mod 8, but this is mod 8 solely testing mod 5. That's why I mean the modules all linking with one another. Okay?
So what do you say about this one?
There's no such thing as a hard. See, the thing is, my students, since I told them mod 8 was the hardest, they doubled down, they revised it, and it became one of the easiest for them. So it really depends on how you take the year. I would say typically when you start off though, mod 8 would be the hardest, when you're learning from the get-go. Alright, let's move on. What I might do, I might give you all 5 minutes, bit of a breather, and then go through some more challenging questions, okay? So stand up, stretch, use the restroom if you like, get some water, and feel free to go outside, get some fresh air, and we'll recap in 5 minutes, okay? So exactly 2:53-ish, come back. And if you have your assessments for me, show that to me. Let me just get water as well. So take a 2-minute break. And same for Mithilesh, Gerald, and Risa. Just take a 5-minute break. We'll recap that.
Yeah, all good.
All right. So we're going to do a couple more questions, and I'm going to move us on to mod 6. So we'll jump right into it. So.
So what day will you do the exam?
So it's not going to be next week, it's not going to be the week after, it's going to be the week after that. Okay? That will be, I have to give you a date. Fourth of December. Okay. Maybe, yeah, it'd be good if everyone wrote that down, because I won't remind you every week, but you will be sitting on the 4th. Okay, good. Let's move on to doing a couple more questions from these papers. So Sydney Grammar is known to have one of the best trial papers to practice on, because yeah, it's hard, challenging, and also because yeah, and it's one of the top schools in the state. I think it's very good practice to do their questions. How about we start with this? Pretty easy question to do, but we'll go from there, okay? So I want you to focus on your speed for these questions, right? So don't spend too long reading it, straight to it. I want you to answer it as fast as you can. These questions are very doable. First person to get your answer, just raise your hand up, even for virtual students. Must be the last 30 minutes, we'll start on 6, the basics. Okay, I'll be right back. Okay, so what's that plan of attack? We'll start with Maher. What's the first step we do? Good. Alright, so you've written your equation, Maher. What's the next step? Yep, so what are we doing next? Well, what haven't we done? What's the next step we should always be doing? Data, right? Good, and KSP is part of that data. So what we have now is we've been given a solubility, and we need to find the KSP. Now, if I ask you to calculate KSP, don't copy paste your data to your answer, okay? You're not getting marks. You need to derive it. What is this value here? How do we write this mathematically? Prabhat? 34 grams per 100 ml. What is that? It's a concentration, right? That's what I want you all to think and understand. So you've got a concentration here. Concentration of this value is 36.4 grams per 100 ml. So what's the mass per liter? Is it 3? Should it not be 364 grams per liter? It's 36.4 per 100 ml times it by 4. Times it by 10, numerator and denominator. Okay? Good. So that's our concentration in grams per liter. So then we've got in 1 liter, what would the moles be? Because remember, you need to find moles per liter to find KSP. If you have KSP, you can find moles per liter. You need to remember that relationship. Yeah? Good. So how do you convert this? So in 1 liter, the mass of Al through SFO3 is equal to 364 grams. So Mithlesh, what's the number of moles that you got? Mithlesh, what's your answer? Number of moles of aluminium sulfate.
Give me a second.
Yeah. Who's got an answer? Is that it?
Okay, I got 1.06.
Okay, good. So we can maybe store that as A. Because what is that also? Do you all agree that's also the concentration? Because if we do C equals N on V, well, V is just 1. Good. So now can we find KSP? KSP is equal to, if this is X, what's the concentration of, sorry, we didn't balance this equation, so we're about balance this one.
That's why I can't see you.
That's all right. So we've got, all right, I'll help you out here. 2, 3. All right, so KSP is equal to, you'll agree, for every X moles per liter of aluminium sulfate, we have 2X moles per liter of aluminium, and how much sulfate? 3x. Does everyone see that? Because it's stoichiometric ratio. Ravel, can you see this?
Slightly.
Do you want to maybe sit forward? Is that be better? Do you want to maybe
I
sit
think I won't be able to see from there because it'll be.
Yeah, maybe. Would you be able to swap with each other? Just so you can see.
I really don't have to. I can just maybe get it out my laptop maybe.
Whatever you prefer. Okay? If you want to switch, you can.
No, sorry. For now.
Okay. Right. Okay. Thanks, Sam. We've got 2x squared times 3x cubed. All right. And we know x is equal to 8. So what's our answer? Okay. 37.04? Okay. What do you think about this? High, low, soluble, insoluble? Did you get different values or? Okay, good. Yeah, it's very soluble. I think you would have picked that up when you saw 364 grams per liter. What did I tell you all the cutoff for solubility was to be insoluble? Yeah, less than 1 you're insoluble. Less than 0.1 you're definitely insoluble. So between that's partially soluble, you can say. Okay? This is a very soluble salt. Good. So that's your K2 value. How many sig figs? 3. Round it off to 37.1. 3 sig figs. Easy. Oh, apologies. 37.0. Good. Any questions there?
Prithvi,
Yeah.
I think I got a different answer for that.
Okay, Pranav,
Sorry.
what did you? 144. Risa, is that what you got?
I got 147 because I used the
I
used
got
the
7 as well.
yeah.
Yeah? Okay. What was the mistake? Huh? You added it? Come on, it's a K question. Okay, 147. We can round it up to, this would be 150 if we're doing, we're doing 3 sig figs, right? Yeah, so 147 has already been rounded off. Okay, good. Not too bad of a question. Happy to move on? Okay, maybe we might do one more if I can find another hard one. Otherwise, this is more brute calculation. Question 25. This will be a final question.
Could you send it on Teams?
Sure. Okay, here's the question. And this will take us into mod 6. This is very much just a calculation question. So you don't need any mod 5 knowledge for this. This is just, if anything, it's linked to mod 6 because it's neutralization, so acids and bases. But you definitely can do this with year 11 knowledge. I might reach. Sorry, Gerald and Mithlesh and Risa, I'm just going to rejoin the class recording, okay? Give me 1 sec. Okay, I'll share my screen again. Okay. Again, I will not say anything. Start calculating this. This is going to be testing what you learned with spectroscopy with me. I want to see if you can put it in practice. Jared, what does it mean to be hydrated? When you have a hydrated salt solution, what does that mean?
It forms a complex with water molecules.
Very good. It forms a complex. It's chemically bonded. Very good. How about when it dissolves, everyone? So if this hydrated solution dissolved, as you know, it's sodium carbonate. Is it a soluble salt or insoluble? Soluble or insoluble? Sodium is a group 1 metal. What was the number 1 rule? Soluble, right? So this is a soluble salt. So when it breaks up into sodium and carbonate, what's going to happen to the water? Break apart, right? So it's important to understand that when you dissolve that, it will form sodium and carbon ions, just as normal sodium carbonate would. So if I had 1 mole per litre of hydrated sodium carbonate, when it dissolves in solution, what would the sodium carbonate concentration be? So unhydrated, just Na2CO3. I had 1 mole per litre of hydrated sodium carbonate, it dissolved, what would the unhydrated concentration be? I want you to imagine, mine here is a water molecule, is complex to you two. When you eventually split apart, how many pronouns do we have? 1. How many branches do we have? 1. That's what I'm trying to get you all to understand, right? So if you have 1 mole liter of hydrated sodium carbonate, even once the water breaks off, you still have 1 mole per liter of sodium carbonate. That's to help you out with this question. Concentration will not change for unhydrated and hydrated. And think about what will. I need you all to get started. Even if you're stuck, start the steps that I taught you. Chem is very automated. If you follow the same steps every time, enough practice, you'll always get the answer. Is this someone's pen? Please refresh. Right back. Okay, so who's got an answer? Mithish, Gerald, have we got an answer?
Not yet.
Okay.
Which part?
For C.
No, not yet.
How about in class? How are you going? Think about your equation. Think about your equation. You sure that's where you're going? Yes, but it's okay, guys. It's a carbonate salt. Is it salt and water? It's a carbonate salt. Anyone remember? When a carbonate salt neutralizes, what do you form? Nothing.
CO2 and
Perfect. Thank you. All of our equations were incorrect. So we messed up the first part, so the entire question will be wrong. So we'll do this together. But this, hopefully this shows you, even though mod 5 is easy, we still need to perfect the harder level questions. Some questions will mix all the 4 modules and you won't even know which module they came from. Such as this one is technically more year 11 prerequisite knowledge than it is year 12. You don't need to know anything about acids or bases to do this. So let's do this together. The equation is sodium carbonate plus HCl. Because remember, it's not the water molecules here. Because remember I told you, the second you drop it in water, the water breaks up, right? So once we've made it into solution and then we've neutralized it, we have to add HCl. Will this reaction go to completion? Right? All neutralizations go to completion. It's basically one of year 11 reactions. So what do you form? Sodium chloride plus water plus CO2. So I want someone to balance this for me. What's the first thing I do, Pranav? Okay, so what are you going to do to the NaCl? Good. Now you've got 2 chloride, what are you going to do? Good. So now you've got 2 hydrogens, does that match up? Good, and you have 3 oxygens on the right, does that match up with the left? Good, so it's a balanced equation. So what are we going to do now? Now we're going to have our data. Does everyone agree? So the data here is the mass of the hydrated sodium carbonate crystals. Is that even in the equation that we've written here? No, so we're going to have to write that separate. Mass of sodium carbonate times XH2O is equal to 27.82 grams. Okay? And it was dissolved in water, made up to 1 liter, 25 ml of that solution. What should we do straight away? Yeah, but when there's a lot of steps, what should you do? You go. Now we're starting to get the hang of things, right? So what's happened here is we're going to write B equals to 1 liter. This is our original sodium carbonate times XH2O that was added to 1 liter of solution. From that, what did we do? From that, we took 25 ml. So what do we call that? Is that dilution? It's not. Dilution is when you just add water. It's not when you take a tiny bit of a solution out, right? That's not dilution at all. In fact, I'll just call that step 2. Okay, 25 ml of that solution is then combined with what can you say though about the concentration of the Na2CO3? Doesn't change. So whatever concentration of Na2CO3 was here, it will also be the same for that C1, or will it also be here? Yeah, good job. All right, what was that combined with? Yeah. All right, concentration of HCl is equal to 0.1. Volume of HCl is equal to okay. So the first question is, find the concentration of sodium carbonate neutralized by the HCl. So what are they asking here? What are we being asked to find? Do we have a C2 here, or did we just say this is still C1? Still C1, so what are we finding? C1. Very good, right? So everyone, we've got a C and a V of HCl. However, what do you need to find? We've got a C and a V. There you go. See how easy chem is. You just follow the exact same steps I taught you, would always get your questions right. Okay? So the number of moles of HCl is CV, which is equal to, rheostat, what did you get for concentration of HCl?
Sorry, the concentration, do you mean the number of moles?
Sorry, yes, number of moles of HCl.
Yeah, I got 4.88 times 10 to the minus 3 moles.
Yep, that sounds right. 2 times it by, yep, good, easy. So we'll store that as A. Then what's the number of moles of sodium carbonate? Remember, this is just neutralized by exactly that amount of HCl. We can apply the stoichiometric ratio. What's the ratio here? 1 to 2. Does anyone know the trick? So what I do is I always write, so whatever I'm trying to find the number of moles of, I write the number in front of itself. So what number is in front of itself in the chemical equation? What number is in front of the other substance? 2. And then I write the other substance. Right. So you just have to remember that little step in your head. These questions will be super easy. I guess I call this itself over other. Okay, very tiny thing. It's a bit of year 11 chem. So that's equal to A on 2. So then what's our concentration of Na2CO3 going to be? Good. C equals N on B equals to A on 2 divided by, what are you going to divide it by? One liter? You sure? Would it be 25 plus 48? You know what you're going to find next. So if we hand up, you think you're going to use 25 plus 48. Or not? Mithaj, agree, disagree?
Which part?
So we're saying, what V value are you going to put to find the concentration of Na2CO3?
1 liter.
Isn't it 25 milliliters?
Gerald, what do you think? Break the tie. 0.5 milliliters or 1 liter, or what the in-center students have mentioned, which is 25 plus 48.8.
Wait, this thing lies.
I'm not sure now, honestly.
Yeah, because think about this, right? Think about what you're going to find next. If we follow Mahi's way, we find the total concentration. We're going to find the concentration of sodium carbonate in this mixed solution of HCl and sodium carbonate. You can't do anything from that. You can't go back up, right? You need to go back to number of moles to find things. But what you can do is think about this. You've got the number of moles of sodium carbonate. What volume was that number of moles delivered in? 25 ml, right? That 25 ml solely had sodium carbonate in it. So that 25 ml would have had that amount. Where did that 25 ml come from? The 1 liter beaker. So if I can find the concentration in the 25 ml, I can find the concentration in the 1 liter beaker, and then I can start working out the whole hydration, X, which is what the next question is. So if you're stuck, work through, a little thought logic, or apply little scenarios in your head. So that's exactly what I did. So does everyone understand now why you're going to pick 25? You can't do anything if you work with 25 plus 48. You need to go back up. I guess Riasat mentioned a very important point, which is we are working back up to find our answer with most of these questions. So think about what you would do next if you did follow a step. So it's 25. Good. The reason I'm asking you this is because in your exam, you don't want to get stuck on those tiny things and lose the entire question. Good, so what's that answer for C? As fast as we can. Mithilesh, did that make sense why we're not picking a liter? Because the number of moles here, sodium carbonate, was delivered by the little 25 ml test tube.
Yeah, I did the same thing, but I didn't realize what you were asking.
Okay. Alright, so what do we get?
76 times 10 to the minus 8.
Good. So that's C1. That's the same as a concentration in that 1 liter. Everyone with me? Good, so we've got our answer for A. What about B? Calculate the mass of water in the hydrated crystals to find the value of X. They're helping you out here. They should have just said find the value of X. But now you know you need to find the mass of water. To find the mass of water, what must you do? I want to hear some ideas right now. Yes, and then subtract it from to find the mass of. There you go. That makes sense to everyone? You're working with dehydrated sodium carbonate. You know its concentration. You know the volume. What can we find? Number of moles. After number of moles, what can we find? What can we subtract that from? What can we find? That's the water. I'm not going to say anything now. I want you to find the answer as fast as you can. You literally have 2 minutes. Good. Mithilesh, have you got an answer?
Yeah,
Okay, good. What number have you got?
I got 10.
Okay, good. I want everyone else to calculate this and tell me if you got 10 or not. Imagine there's 1 minute till pens down. It's your last question. Do it as fast as you can. So those who get your answers very quickly, or you're already finished, This is where you can quickly squeeze in some additional questions from the additional question booklet as well. But we're pretty much ready to do this now. Okay. All right, let's do this. So what was the number of moles of Na2CO3? So you would have used CV, you would have used the 1 liter as your V, because that was a 1 liter in the beaker. You would have used this value here as your C. We could have stored that as A. What do we get from number of moles? Maya? Yeah, same thing, right? Yeah, because you're timesing it by 1. All right, so what's your mass of sodium carbonate now? What do we get? You should have multiplied A by the molar mass of sodium carbonate. So what do we get? Joe? What do you get for your mass?
Mass of what?
Sodium carbonate? 11 point.
Mass of sodium carbonate was 10.344.
10.344? Okay. Double check what am I here? 10.344?
Yeah.
We'll store that as B. So then when you subtract B from 27.82, Gerald, what do you get as your mass of water?
You get 17.475.
475. Sure, let's store that as C, right? So now, how are we going to find X? Gerald? We'll pass it on to Mithilesh. How are you going to find X?
Okay, so 17.475, like the moles for water. Right, that. So you get 0.97 moles of water.
Good. So you found the moles. So you've got the mass of water, you're just converting it to moles. So you can say number of moles of H2O is equal to mass on molar mass. That's equal to C divided by the molar mass of water. So what do you get as your number of moles?
0.97.
0.97. Okay. So what do you do next?
So you would divide the number of moles of H2O by the number of moles of sodium carbonate.
Okay. Now, does everyone understand why he did that? Why do we divide the number of moles of H2O with the number of moles of sodium carbonate? Now, we're trying to find, remember, when you're working with salts, what formula are we working with? Empirical formulas, all year 11 stuff. What is empirical formula? When I say NaCl, does that mean when I have a ton of salt, imagine there's a huge ton cube of salt. There's only 1 atom of sodium and 1 atom of chloride? There's billions, do you all agree? What is the NaCl representing then? The ratio, simplest ratio. So what we need to do here is we need to find the simplest ratio of Na2CO3 to H2O. Does that make sense to all of us? So our number of moles of H2O is 0.97. So what I like to do is I write it like this: H2O dot dot Na2CO3. And I know there's 0.97. We'll store that as, I don't know, D. Okay, and Mithilesh, what was the number of moles of Na2CO3?
0.0976.
976. All right. You know what? I'll write it like this. I've got 0.97. Okay. So what you do next, everyone, is you divide by the smallest number. So if H2O was a smaller number, you divide both the numbers by H2O. Right? But in this case, since NO2CO3 is a small number, you divide everything by Na2CO3 because you're trying to find the smallest ratio. So what should you get now? 1, 2, is it 10? Yeah, and then you just round it up to the nearest whole number. So the answer for X is 10. Do you see how this is much of year 11 knowledge? This is a trial paper. It's not like they can't ask you this. This is the year 11 stuff you need to know really well. Mole calculations, you need to know really well. What else do you need to know very well? Redox reactions, you need to know how to pick up whether the reaction is redox. Do you remember oxidation state? You should know how to read oxidation state for a reaction. I'll take you through all of that again. But on that note, we are done for today. So good job. Next week, we'll properly start mod 6, okay? And for those of you who are doing acid-base, if you want to ask me any questions, feel free to ask it as well. Do you have any questions about acids or bases? You haven't started it? Okay. We'll do your research next week. Tell me what questions you have, and I'll also test you. Is it due this week? You haven't started? Okay. Make sure you do well at that. You don't want to get hit back in your first assessment task. It'll be harder to catch up after that. Has everyone found out how many students band 6 at their school? Okay, so then you should aim to be at least top 20, right? So to make sure you get a high band 6. And then same for all of your schools. Because that will tell you what rank you need for chemistry, right? You might think rank 3 is good, but if your school only gets 2 band 6s, you're not there yet, right? So that's why it's so important to look at your rank versus your cohort this year. Okay? You can all find that out. Search. There's a website called HSC Ninja. You find out all the students, what their band 6s were. You can search past years. You can do anything. My friend made that website. He's in medicine now. And the interesting thing is, he makes $40,000 a year just off the website because of ads. So I guess that tells you how good it is to know how to code while also doing another degree. It has a good synergy. But anyway, I'll leave you all to it. Have a good week. So Nicholas, Gerald, and Riasat. I think next week, Sydney boys, since you have your sport commitment on, your class will be on Sunday, right? You can still, can you do Saturday? Okay, so you can stick to the Saturday class. It's the same, we're going through the same content. The only thing is, for those of you who are solely Sydney boys, I would encourage you to let more friends know about your class as well, so we could create a focus group class for you next week. So let friends know, and hopefully I'll see a few more Sydney boys students next week. Okay?
Yeah. All right. Thanks, Prithvi.
Take care. Have a good week. See you.
Yeah, you too.
Students, and all of you are free to go. Thank you. See you guys.